Hi everyone. So today we'll be solving the question reverse space from Strivers SD sheet, and this will be the last question from arrays part 3. So the question says that given an integer array nums, we are having an integer array nums and return the number of reverse pairs in the array. So what is a reverse pair according to this question? A reverse pair is a reverse pair which have I is less than j, like the index value of I is less than j, and also the value of I should be twice the greater than twice the value of j, right? So that means I should be greater than j by 2 times. That is the basic things which you have to satisfy in this question to do this particular question, that is reverse space. So you can see, like, I'll like the brute force, we will start a for loop and then again another for loop, that j will run from I plus 1, and then I will just simply put this, this condition. That's the brute force, right? I'll show you. This is the normal brute force, right? In reverse space, and then because you have to count the number of pairs, right? So if if nums I is greater than this twice of nums j, then just count plus plus and then return. But this is giving a big of n square solution, as you can see. I don't know why it's not working here. Okay, so you can see two for loops I'm using. So it's not a best solution, right? Big of n square. But the constancy here is 5 into 10 to the power 4, which is huge. So definitely we have to go with a better solution, right? So this is one of the hard question asked in most of the interview. Do not get worried. Like, you can check that. Uh, See, 1 3 2 3 1. You have to check, like, indexings are always in order. Indexing, like, I will be there and then j, like that, right? But now if I tell you, like, what are the different possibilities, like how can you, like, intuitions to solve this question, here is explained very well. One of, like, general principles behind this is one of the best way, I think, to read. I would suggest to please give a read on this particular article, which is written very great way, right? So if you could just see, we have to, like, the index have to be very proper, right? This index thing, like, index I should be, the index value of I should be less than j. So we can just check first this part with this, like that, something like divided in between. So something like this when it comes now, like, see, I have showed you the brute force. Now how to get the intuition? We can check this with this, right? Basically we're dividing it, you can see. So whenever something divide things comes, what is the DKC that we use to solve such question? Anytime we get this, like, we can divide the array into parts and check. Suppose dividing 1 3 2 and then checking it with 3 3 1, right? Definitely we are gonna get 1 here, right? Because 3 1 is also a pair, right? Because 3 is twice greater than 1, right? And also another pair, what can be the pair, that is 3 and 4. First we have this 3 and 1, another is 3 and 1, this 3 and this 3 also. So we can just check, see, we can break it into array, and then so anytime something like divide thing comes, then you just remember about the mart sort and divide and conquer, simple. So this is the simple mart sort question, okay? Nothing else. We just did everything. I have also made the video on Marsort. We just have to reverse, like, this is the main code, and just we have to count the pairs, which is this. Just see, using this is the condition, right? For condition we have made another function. So this is the condition to check, that is if array of I is greater than this or not. So simple mart sort, like in mart sort, what we do, we take a temporary array, then we take two pointers, that is a left pointer and a right pointer. So basically, if you just see this example one, So if we just break it into like this, 3 and 1. Okay, this is the partition. So left pointer is basically denoting this, and this is from mid. So right is basically from mid plus 1, right? Because it's a 0 bit best index and therefore mid plus 1. And then while left is less than is equals to mid, and whether till now this is the mid pointer, this is the mid, so left is equals till left is coming and meeting mid, and then right is less than is equals to high, this is the high which is 1. Then just check whether if left is lesser than the right, then just push it. Okay, else then right, else right will shift, because we are sorting in ascending order, right? First we will sort, basically dividing it. So what will happen, basically, since 1 is greater than 3, 1 is greater than 3, so 1 is smaller than 3, so 1 will be here, and 3 is again greater than 2, so 2 will come here. So since 2 is smaller than 3, right? 3 is 3 smaller? No. Therefore left plus plus, left will come here and we will push there. So 2 will come here and 3 will come here. Else we will do like right, we will check for the right one. Okay. So till this it became already 1 3. This is the match sort thing happen. Any element is suppose this is already sorted. Okay, this is already sorted. So just any element is left here, just put it all. This is a proper mark sort question. For that you need to check the mark sort video. Element is left on the left side, that is this part, then please add those. Or if any element is left on the right, but then add those, because it's already, we have already done the sorting based on the 2 array. As simple as that. So now finally we have taken a temporary vector to store this 2 thing. So we are shifting that to our original array, okay, which is this. Now this is the final thing. Okay, this is the condition that we have to check with right is equals to mid plus 1, of course, and this is the count, the final answer that will be returning, right? Till right is less than is equals to high, and what you have to check whether this 12, do not get tensed while this question. If you just explain this much also in the interview, you will be getting, because it's a very tough question. So now the condition, if array of I is greater than twice of the array of the right, left is greater than the twice of the array of right, then right plus plus, then please go move and add that count. Okay, and then return count, and then finally call, this is the march sort function where I'm calling all of this march sort things. Okay, so this is the thing, and this is for the mid. Okay, and again this is all the march sort call, and finally this is the question reverse space, where I'm finally returning, calling the march sort function. I'll show you with the dry run. Okay, you will better understand it. So this is the number we have, 1 3 2 3 1, and after that what we have, like the left part is 1 3 2, we have divided it, see 1 3 2, and the right part is 3 1, right? Now after sorting 1 3 2, it will become 1 2 3, right? And after sorting 1 3, it will become 3 1, it will become 1 3. Now if we are checking between them, so of course 1 is not going to work with 1, right? So 3 can work with 1 definitely. So 3 is twice 3 1 is satisfying the condition, therefore plus 1. Again 2 is also greater than twice of 1, so this is also 1, counter will be 1. Again if you see in this, 1 3 is also a pair, right? 1 3 is also a pair which is satisfying the condition. Okay, so what I was saying that, okay, 1 3 is not a thing. Okay, so here we just got confused with the condition, and so the total count is 2 here, and the ChatGPT made a mistake here. Finally it's giving reverse pair 2, but it is wrong. Okay, it's only 2, because here only 2 1 is satisfying the condition, 1 3 satisfying the condition, and it made a mistake over here. See, 3 1 is making a satisfying the condition, and again here 3 1 is again making the condition, satisfying the condition. So final the count will be actually 2, which is this, because that was chat gpt's mistake. Okay, otherwise when you compare you will also check here also. Okay, you will check in this part also. 3 1 is before sorting, right? Therefore finally the answer will be 2. I hope you got the pairs, that is 3 1 and this 3 1, index number 1 4 and 3 4. So yeah, what will be the time complexity for this? Just think for a while. See, it's completely two pointers thing. Something will be in log m, right? Just think for a while. So the time, let's discuss the time complexity for this particular question. Okay. Of course, it's a two pointer or a march sort. Therefore, it will be big of n log n, and the space complexity will be big of n for the temporary vector and big of log n for the merge sort calls, like all of these calls you have done, no? That's why. So I hope you enjoyed. This is a very tough question, but I tried my best to explain. But until and unless ChatGPT did some mistake in dry run, else everything is very. I hope it's pretty clear. Yeah. So keep lit coding. Bye.